In this example, we are given that a block of mass m is released from rest from a height h above the light pan attached to a vertical spring of force constant k mounted on floor as shown. And we are required to find the maximum compression in the spring by the block. In the solution, let us first analyze the situation. When the block is released from rest, its initial kinetic energy was 0. The only force acting on the block will be its weight mg, because of which it is falling down. When it will strike the pan, it will start compressing the spring in downward direction, and spring will start opposing the block in upward direction. Or we can say spring has started doing negative work on the block when it comes down. Let us consider block compresses the spring by a maximum distance x, and at this position the block will come to rest again. So in this situation, say initial point is A, final point is B. We just use work energy equation from A to B to get the value of x. So we can simply write using work energy equation from A to B. We can see initial kinetic energy of the block was 0. It has fallen totally by a distance h plus x, and throughout the motion mg was acting on it in downward direction, so it is doing positive work. We just add mg into h plus x. Spring as opposing, it is doing negative work. As a spring is compressed by a distance x, the potential energy which is extracted by a spring, that will be half kx square. That is the negative work done by the block. Finally, at position B, we can again write, as the block is at rest, its kinetic energy will be 0. We can see this is a simple quadratic equation. We just rearrange the data. We are going to get kx square minus 2mg into x minus 2mg h is equals to 0. And the value of x in the quadratic equation can be directly obtained by a result. That will be negative of coefficient of x, it is 2mg, plus we just ignore negative sign as there is no scope of negative compression. It is root of the square of coefficient of x, that is 4m square g square minus 4 times the coefficient of x square and the constant term, it will become plus 8mg hk divided by twice the coefficient of x square. So this is the maximum compression in the spring because of the falling block. So this will be the answer to our problem.